Hi, welcome to Physical Science 1.3 Slopometer. This is going to lead into a stack of graphs, and we're looking at a qualitative acceleration. Remember, qualitative means no numbers. So your slopometer is going to be one of three things. It's going to be flat, it's going to go up, or it's going to go down. Your pencil is going to become your very own handy-dandy slopometer. When the pencil that lines up with the graph is flat. Now we're reading the pencil. The slope is 0. Think skiing, Kansas. It's flat. You don't go anywhere. So that slope equals 0. When the pencil goes up from left to right, that line has a positive slope. It is going up. Think a ski lift that takes you up to the top of the mountain. When the pencil goes down from left to right, that line has a negative slope. It is going down the mountain. So if you place your handy-dandy slopometer on top of the graph, like the red line is on top of the blue line, the blue curve, so that it lines up with the graph and move it from the beginning of the graph to the end of the graph, the slope of the red line, your pencil, is the slope of the blue graph at that point. So every time you do this, you have to have some necessary information. 1, every time you interpret qualitative acceleration, you need the following. 1, what is the starting point? This is going to be positive, negative, or 0. 2, what direction is it going? Again, positive, negative, or nowhere. 3, what is the starting velocity? So you're going to line your pencil up with the beginning of the graph and read the pencil. And then finally, what is the object doing? We're going to walk through several examples. The doing is going to be one of three things: going at a constant speed, speeding up, or slowing down. Explanation and directions. 1, starting position from the XT graph. That's the first thing you get. 2, you need the direction from the XT. So when we do this, you're going to list the starting position and then the direction from the XT. Then you're going to draw the VT. You're going to put your handy-dandy slopometer down, and you're going to draw the VT. Then you're going to record what the starting velocity was. Then you're going to draw an AT from the VT. Then you're going to identify what it's doing. If the VT and the AT are in the same location, meaning on top or on the bottom of their particular graphs, the object is speeding up. If they're not in the same location, it's slowing down. So this is what a stack of graph looks like. You're going to have an XT, VT, and AT. This is going to be given. This is your XT curve, okay? From that XT, first thing we're going to look at is the starting position. It starts positive, up away from 0. And then the direction. It goes in a negative direction. Now we're going to draw the VT. So if you line up your handy-dandy slopometer at the top, it's 0. So you put a mark at 0 on your VT graph. Okay, it'll be where V and time intersect. Then if you put your handy-dandy slopometer, which is your pencil, at the bottom of the graph and line it up with the curve itself, it's going to show you a high negative number. Well, high negative is going to be the very bottom right corner of the VT graph. And then you draw a line connecting those. Now we're going to do the AT graph. So on our list, the VT, the starting velocity was 0. Okay, and then we're going to do the AT graph. Well, the VT graph has a slope that is negative. It's going down, and so we will draw a negative slope for the AT graph. So let's look at our description. The object started at a high positive position. It moved in a negative direction. It had a starting velocity of 0, and notice that the VT graph and the AT graph are both in the bottom section, so this object is speeding up. Let's do another one. You're given this XT graph. First thing, starts at 0, moves in a positive direction. Put your slopometer on the XT graph at the beginning, and it's 0, so you put a dot there. And then at the end of the graph, and it's going to be a high positive. So you draw the VT graph to show it went from 0 to a high positive. Then you would record in your list of important information that the starting velocity was 0. Then we draw the AT graph, and the AT graph should be positive because the VT goes from 0 to a positive, so the A is positive. So reviewing, starting position at 0 or the origin, moving in a positive direction. Starting velocity was 0, and notice that both the VT and the AT are on the top of their respective graphs so that you have an object that is speeding up. Number 3. Number 3 looks like this, okay? And there's only 4 of these, by the way. Number 3 looks like this. So the starting position is positive. The direction is negative. But when you go to do the handy-dandy slopometer and you put it at the top of the graph, you now have a high negative number. That's going to be in the very bottom left-hand corner on your VT. It's a high negative number. And it goes at the bottom to be 0. So you draw your VT from bottom left to middle right. The starting velocity is a high negative. Okay? This line goes up from left to right. The VT graph goes up from left to right. So your acceleration graph is positive because you're going up from left to right. So reviewing, this object started at a high positive position. It's moving in a negative direction. It started with a high negative velocity, and it's slowing down because the VT and the AT are not in the same location. Last one. This is the graph that you're given. The starting position is 0, moves in a positive direction. The VT starts at a high positive and moves to 0, which looks like this. The AT then would be negative because the V is going down from left to right. So the object started at the origin, or 0, is moving in a positive direction. Starting velocity was high positive, and this object is slowing down. All right, hope you got those. We'll see you later. Thanks.